So for today's lesson, we're going to have our quarterly exam day review. So it's going to be our review day 1. As a reminder, your quarterly exam is scheduled for as follows: Tuesday the 24th and Wednesday, March 25th. Okay, so the first thing we're going to review is slope. Slope is defined as follows: rise over run. And remember, our rise corresponds to our y values and our run corresponds to our x values. So slope is going to be calculated using the following formula: y2 minus y1 over x2 minus x1. And as a little reminder, our coordinates is always x comma y. So let's practice. Let's find the slope of the following points. I give you the coordinate 1 comma negative 19 and negative 2 comma negative 7. So we're going to calculate it using the formula for slope, which is y2 minus y1 over x2 minus x1. As a little reminder, so this over here is x comma y, x comma y. What I'd like to do is this first set of points that I see here, I like to assign as x1 and y1. In this second set of points right here, I like to assign as x2 and y2. Remember, you can't go ahead and change and say, well, I want this to be x1 and this to be y2. It doesn't work like that. Like, this entire set has to be either x1 y1 or x2 y2. And same thing over here. This is either going to be x2 y2 or x1 y1. So you can't just go ahead and say, well, I want to use this as x1 and this is x2 and this as y1 and this is y2. It doesn't work like that. So let's calculate the slope of these points. So we have 1 comma negative 19 and negative 2 comma negative 7. So we're going to use 1 as our x1 and negative 1 as our y1. And then we're going to use negative 2 as our x2 and negative 7 as our y2. So when we plug it into our formula, it's going to look like this. So we're left with negative 7 minus negative 19 over negative 2 minus negative 1. What's important is when it's negative, like it is over here and over here, you don't get rid of that negative sign like we just did right over here. You keep the 19 negative, because even though some of you are like, oh, but my formula already has it as minus, you don't get rid of that negative stays. So what happens over here, you got a double negative. So what happens? Well, now it becomes negative 7 plus 19 over negative 2 minus 1. What we go ahead and do is we go ahead and simplify. Negative 7 plus 19 gives us 12, and negative 2 minus 1 gives us negative 3. So because this, if you put it in your calculator, comes out nicely, our slope is negative 4. And some of you, just as a little reminder, because it's a whole number, it's negative 4 over 1. So we are going down 4 units and to the right 1 unit. Let's find the slope of these points: 20, 8, and 9, 16. So what I went ahead and did was I used this as x1 and y1, and this as x2 and y2. So what we go and do is we do 16 minus 8 over 9 minus 20. When we do 16 minus 8, we get 8, and when we do 9 minus 20, we get negative 11. So our slope for this problem is 8 over negative 11. So what it's telling us is we go down 8 into the right 11 units. It doesn't matter that the negative sign is with the 11. It just matters that the slope is negative somewhere. So I kind of like to always put it onto the top. So I would say we go down 8 units and to the right 11. So with that comes slope-intercept form. Slope-intercept form is y is equal to mx plus b. As a reminder, our b is our y-intercept and our m is our slope. So in this problem over here, we're going to identify the y-intercept and the slope. I give you guys y is equal to negative 1/2 x plus 2/3. All I'm looking for in a problem like this is for you to tell me what your y-intercept is and what your slope is. So your slope is negative 1/2. What's important is as long as there's a negative in front of here, you have to include that. So our slope is a negative 1/2 and our y-intercept is 2/3. Now, if I give you your slope, y-intercept and your slope, now I want you to write this into slope-intercept form. Now I want you to plug these numbers in and give me the equation. So we're going to work with y equals mx plus b. And all you're going to plug in, you see how we have an m here, and you see how we have a b. Instead of using b, I might say y-intercept, and instead of using m, I might say slope. So whenever you see m, think of slope, and you see b, think of y-intercept. So we go ahead and do that, and we get y is equal to negative 9/10 minus 3/4. All I did here was plug this in for m and plug this in for b. The next thing we work with is point slope form. Point slope form is y minus y1, which is equal to m times, and then in parentheses we have x minus x1. With point slope form, you're only plugging in for m, y1, and x1. This y here and this x here, they don't get touched. They stay exactly as they are. This stays y and this stays x. All we're plugging in for is m, which is over here, y1, which is over here, and x1. Your m, so which is your slope, your y1 and your x1, they'll be given to you. So let's practice. When we write an equation in point slope form, I'm going to give you something that looks like this. A line passes through the points -3, 6 and has a slope of -5. What is the equation of the line? So your first thing, I ask you point slope form, we're going to get this formula. Y minus y1 is equal to m, and then in parentheses x minus x1. Now you already have your y1, which is 6. We already have our x1, which is -3. And I told you your slope is -5, so we have our m. You have everything you need to go back and plug into this formula. So let's go ahead and do that. So we're left with y minus 6 is equal to -5, and then in parentheses x minus -3. What's important here is, look, there's a minus sign right here, and this is a -3. You don't drop this negative off that 3, you carry it down throughout the problem. So when we do that, we have y minus 6 is equal to -5 times x plus 3. We've plugged everything in. We've gotten rid of, you see how we have these double negatives here, and this is the equation in point slope form. Now the next thing we're going to talk about is standard form. Standard form is ax plus by is equal to c, where a, b, and c are real numbers, and a and b are both not 0. So what that means is you don't want just to have by equals c or ax equals c. So for when we talk about standard form, that kind of goes hand in hand with finding the x and y intercepts. To find the x and y intercepts, we're going to be looking for two things, the x value and the y value. In order to get x, we're going to plug 0 in for y, and then the y, it's going to cancel out, and we're going to end up solving for x. Once we get that answer, we're done for solving for x. Then to get y, we plug 0 in for x. And what that does is it eliminates the x variable. And once we plug 0 in for x, we solve for y. Let's practice. To find the x and y intercepts of 5x minus 6y is equal to 60. First thing I like to solve for is I always like to find x first, and then I like to go and find y. You can do it in whatever order you guys want to do it, but for me, for some reason, I always just like to find the x first. So I kind of just rewrite the equation over here. 5x minus 6y is equal to 60. And since we're looking for x, we're going to plug 0 in for y. So we have 5x minus 6 times 0 is equal to 60. Well, 6 times 0 gives us 0, so we're left with 5x minus 0 is equal to 60. Because it's 0, you don't have to add or subtract by anything, so we're left with 5x is equal to 60. And now at this point, we have to solve for x. And the way to solve for x is to divide each side of the equal sign by 5. So we get 5x divided by 5 is equal to 60 over 5. We can plug it in our calculators. 60 divided by 5 gives us 12. So our x value is 12. The next thing we got to find is y. So we write the equation. 5x minus 6y is equal to 60. We're looking for y, so we want to get rid of that x because you can't have two variables at the same time. So in order to get rid of x, we plug in 0. So we're left with 5 times 0 minus 6y is equal to 60. We go ahead and simplify. 5 times 0 gives us 0, so we're left with 0 minus 6y is equal to 60. Because it's 0, we don't have to add or subtract, and we're left with negative 6y is equal to 60. What's important is you don't drop off this negative at this point. That negative belongs, or that minus sign belongs to this 6y. So to get y by itself, we're going to divide each side of the equation by negative 6. So when we do that, this side, the negative 6's are going to cancel out. And we are left with 60 over negative 6 gives us y is equal to negative 10. So now we found our x value and we found our y value. On the last step, what we do is we put it in an ordered pair. So remember this, it's always x comma y. So we go back and plug in 12 comma negative 10. Parallel and perpendicular lines. This is where most of you were asking me questions this past week on. So we're going to go over parallel and perpendicular lines. So parallel lines, the lines will have the same slope. They're just going to have a different y-intercept. When we write an equation of a parallel line, I'm going to give you the point the line passes through. I'll give you a line in slope-intercept form. You only need this line to get the slope, nothing else. So once you pull out the slope from that line, that equation that's there, it's just going to sit there. You're not doing anything with it. The only thing you need from there is the slope. Then you're going to plug into point-slope form, and then we'll simplify. Okay, let's practice. So we're going to write an equation of a parallel line. It's going to pass through the point 12, 5, and it's going to be parallel to the graph of y is equal to 2/3 x minus 1. So we want to know, what's the equation that's parallel in slope-intercept form? Well, I told you I'm going to give you the point that it needs to pass through. It's going to be parallel. So what do we know about a parallel line? They have the same slope. In this equation, what do we need from this equation? We only need the slope. And the slope in this equation is 2/3. The next thing we're going to do is plug it into point-slope form. So we have our x1 is 12 and y1 is 5. So we go ahead and plug into that equation. So we're left with y minus 5 is equal to 2/3 times x minus 12. So once we do that, the next step is, because we have it's 2/3 times, in parentheses, x minus 12, what we're going to do with this 2/3 is we're going to distribute it. So we're going to do 2/3 times x and then 2/3 times negative 12. When we go ahead and do that, we get y minus 5 is equal to 2/3 x minus 2/3 times 12. And then we go ahead and we multiply that out. So we're left with y minus 5 is equal to 2/3 x. And then when we multiply fractions times a whole number, we do 2 times 12 gives us 24. And then 3, because it's 12 over 1, 3 times 1 gives us 3. We can technically go ahead and simplify 24 over 3. When we do that, we get y minus 5 is equal to 2/3 x minus 8. Now, because we want an equation in slope-intercept form, we got to get y by itself. How are we going to get y by itself? Well, we have this negative 5 here, so we got to add 5 to each side. Because remember, what we do on one side of the equal sign, we're going to do on the other. So I went ahead and added 5. This negative 5 and positive 5 over here, they're going to cancel out, and we're going to be left with y is equal to 2/3 x minus 3. And that is our final answer. Some of you are going to ask me, well, how did we get negative 3? We got that from doing negative 8 plus 5. So your final answer for a line that's parallel to a line passing through 12, 5 is y is equal to 2/3 x minus 3. Perpendicular lines. These ones are a little bit tricky. So the lines are going to have opposite reciprocals. What do I mean by an opposite reciprocal? So if you have a negative 3 over 2, the opposite reciprocal, you flip it and change the sign, would be 2/3 or 2 over 3. The opposite reciprocal of 5 would be negative 1 over 5. And the opposite reciprocal of 4 over 1 would be a negative 4. So when we're writing an equation of a perpendicular line, once again, I'll give you the point the line passes through. I'll give you a line in the slope-intercept form. You only need this to get the slope, nothing else. Once you get the slope, remember, because we're working with perpendicular, you got to change the slope to become the opposite reciprocal. Then we're going to plug into point slope form and simplify. Let's practice. So I want to know a line that's perpendicular. It's going to pass through the point 2, 4, and it's going to be, well, it says parallel here. I'm sorry, it's supposed to say perpendicular. It's perpendicular to the graph of y is equal to 1/3 x minus 1. So I want to know what is the equation that is, once again, it says parallel, it should be perpendicular to the, what is the equation that's perpendicular? The slope for a line that's going to be perpendicular is going to be negative 3, because it's the opposite reciprocal of 1/3. We're going to go ahead and plug into point slope form. So we're going to get y minus 4 is equal to negative 3, and then in parentheses we have x minus 2. Our next step is to distribute that negative 3. And then once we do that, we get y minus 4 is equal to negative 3x plus 6. How did we get the plus 6? Well, we did negative 3 times negative 2. Now we got to simplify and we got to get y by itself. So to do that, we're going to add 4 to both sides of the equation. These 4's cancel out over here. If the mouse wants to move, these 4's cancel out. And then we just combine our like terms. So we're left with y is equal to negative 3x plus 10. This and this, they are perpendicular to each other. How do we know? These slopes are the opposite reciprocal. Last thing I can do is I can ask you, are the lines parallel, perpendicular, or neither? So we have y is equal to 3x plus 6 and y is equal to 3x minus 5. Are they parallel, perpendicular, or neither? These lines are parallel. Why? Because the slopes are the same. The only difference is they have a different y-intercept. Over here, we have y is equal to 3x minus 7 and y is equal to negative 3x minus 8. Are these lines parallel, perpendicular, or neither? These lines are neither. Why are they neither? Because the slopes are not the same and they're not the opposite reciprocal. Some of you guys might say, oh, but Miss Bogdan, you've the first one, you have a 3x, and the second one, you have a negative 3x. For them to be perpendicular to each other, this bottom over here, this equation would have had to have been a negative 1 over 3x. And lastly, if I give you y is equal to 6x plus 7 and y is equal to negative 1 over 6x minus 8. Would these be parallel, perpendicular, or neither? These would be perpendicular because the slopes are opposite reciprocals. The opposite reciprocal of 6 is negative 1 over 6. So that's pretty much the review for today. We just quickly went over Chapter 5. On Monday, we're going to go over Chapter 6, which is your substitution, your elimination, and your graphing the linear inequality. So be sure if you guys have any questions, you guys reach out to me before Tuesday, because Tuesday and Wednesday I'm going to give you guys your quarterly. Okay, guys, have a great weekend.